All right, hi pre-algebra. So today we're going to be starting lesson 3-1. You should already have these notes given to you. So go ahead and pull those out now. If you misplaced it, you can go ahead and download another copy on Google Classroom. So we're going to identify relations and functions. Our two objectives is we're going to identify whether a relation is a function. Okay, so this word function, and we're going to interpret a function. Okay, so we need to know what is a relation, and then we'll talk about what a function is. So a relation is a set of ordered pairs. Okay, so it's a set of ordered pairs. So we use the curly brackets. This represents that it's a set or a list. So a set is also known as a list. So our set of ordered pairs we could have is 0, 1, 3, 3, 4, 2. And this is any list of ordered pairs. And we close the brackets with another curly bracket so that we can tell us that this is a set. So it's a list of ordered pairs. So now we're going to complete the table, graph, and mapping to represent the same relation shown below. So we can show a relation either through a set of ordered pairs, we can show it through a table, we can show it through a graph, and we can show it through mapping. Okay, so these points here, we are going to go ahead and show on the table. So this is 1, 3, and 2. Okay, we can see that 1 goes with 1, 3 goes with 3, 4 goes with 2. Okay? Another way that we can show this relation is on a graph, and all we have to do is plot these points. So when we plot 0, 1, 0, 1 will be here. 0, 1. We would have 3, 3, 1, 2, 3, 1, 2, 3 is this point here, and 4, 2. Okay, so those are our 3 points. And you can label them on the graph if you want, or you don't have to label them, okay? And then for mapping, on MathXL or in Savas, we also call this as an arrow diagram. The way we show this is these are our x values, these are our y values. So we list our values out 0, 3, and 4. And we can list the other values out 1, 2, and 3. And it doesn't have to be in the same order that it was given to us. So we're just drawing arrows to show that 0 goes with 1, 3 went with 3, and 4 went with 2. Okay? So this is another way that we can show this with mapping, or also known as an arrow diagram. Okay? So then what is a function? A function is where each input has only one output. Okay? And the inputs, we call this our x values, and the outputs are our y values. So each input each x has only one y. Okay? So let's look at an example here. We could see that if we had our set of 0, 1, 2, 4, and 3, 5. Okay? When we show this in mapping, 0 and 1, 2 and 4, 3 and 5. 0 goes to 1, 2 goes to 4, 3 goes to 5. Okay? Each input here has only one output. Each input has only one output. Okay? So let's look at a non-example. Let's say we have 0, 1, 0, 3, 2, 4, and 3, 5. Okay? So when we show this in mapping, zero, 2, and 3, and 1, 3, 4, and 5. We can see 0 goes with 1, 0 also goes with 3, 2 goes with 4, and 3 goes with 5. Since this 0 is going to two different values, the one input has two different outputs, and we were saying that each input has only one output. So this is not a function. So we would say not a function. Okay, this is the characteristics. Okay? Another way that we can show a relation is in a graph. And a non-example would be if we had a graph that looked like this. Okay? If you came out with your values, this would also not be a function. And the reason why it's not a function is because we can see that this input of right here also has the same input. And we call this a vertical line test. So we have an imaginary line here going through. And as we slide this line across, so for example, we have a line, maybe I'll say this blue line is imaginary. It's the dotted line here. As we slide it across, we can see it's touching at 2 points. If it only touches it at 1 point, then it is a function. So this one is not a function because we can see it's touching at 2 points. For example, one that is a function, maybe we have a graph that looks like, I'll do a U. A parabola. Okay, something like this. As we have our vertical line test, we have this imaginary line. We can see it is only touching our black graph at 1 point as we slide across. And over here we can see it was 2 times. So since it passes the vertical line test, it is a function. So these are our characteristics. Where the relation passes the vertical line test, it is a function. Where in the relation passes the vertical line test, it is a function. Okay? If it fails the vertical line test, it is not a function. Okay? So that is another way that we can see it. We can see it doing mapping where it's going to 2 different values, or we can see that in a graph. If it's as a set of ordered pairs, it's a little bit harder to identify, but we can still see that 0 goes with 1 and 0 goes with 3. Okay? So now that we have this information here, let's go ahead and look at 3 examples. Frank records, down below it. Jonah is shipping 5 boxes for his uncle. Each box is the same size, but a different weight. The cost of each box is shown. Should Jonah expect the cost to ship a 15-pound box be a unique cost? So will the cost be unique? Well, we can see if we set this up using mapping, we would have 8 and 9, 10, 12, and 14, and 8.56, 8.72, 9.01, 9.55, and 10.03. These values are just coming from the boxes. We can see that 8 goes with this cost, 9 goes with this cost, 10 goes with this cost, 12 goes with this cost here, and 14 goes with $10.03. So if we're paying something for 15 pounds, would it be any one of these values up here? Would 15 go to any one of these values? Probably not. We can assume that 15 would have a unique cost as well. We don't know what that unique cost is, but we know that it would have a unique cost. So would it have a unique cost? Yes. A 15-pound box, it should have a unique cost. Okay, so this is a function. Okay, so it should have a unique cost. All right, let's look at example 2. Frank records the ages and heights of the 6 students he tutors in a table. Is the relation a function? Explain. So we could do this using mapping. 9, so we got our 9. Oh, probably let's put 8 in first. 8, it doesn't have to go in order, but to keep it organized, we can go in order. And 10 and 12. And then the values we have are 45 and 50 and 54 and 61 and 65. Now you only need to write 50 one time. You don't need to write it more than once, okay? So we've recorded all of our numbers. So 8 went with 45. 9 went to 54. And 9 went to 61. Oh, 8 also went to 50. I missed that one. And 10 goes to 54. And 12 goes to 65. So we should have a total of 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 5, 6. Good. So we got them all. Is this a function? So no, it is not a function. And then why? Because each input has more than one output. Okay? All right. I want to highlight this. Let's say we have, this is an extra example. Let's just call this bonus. Let's say we have a relation that looks like this. We'll call this 1, 2, and 3. And we'll have 1 and 2. And let's say 1 goes to 1, 2 goes to 1, and 3 goes to 2. So is this a function? Yes, this is an example of a function because we can see that one input has one output. One input has one output. It just so happens these two inputs share the same output. So if they're coming to the same one, it is a function. But notice when it is v-ing away from it, not a function. 8 is going to 2 different values. This one, 1 is only going to 1. 2 is only going to 1 value. Just so happens they're the same. So this one is a function. All right, so Heather and her parents are going to an art museum for the day. The parking garage near the museum charges the rate shown in the sign. Is the cost to park a function of time? Explain. So we can see that 1 hour is $5, 2 hours is $10, 3 hours is $15, 4 hours is $20, 5 hours is $25. Is this a function? Yes. It's because each hour has a different price. Okay, so we can see that it is a function. If they say if they stay at the museum for 6 hours, should they expect to pay more than $25? Now, according to this information, we should expect that they have to pay more because we can see this is going up by 5. Now, it doesn't ask us how much it's going up by. Should we expect them to pay more? Yes, they should expect to pay more. Okay? So you can go ahead and work on the other handout that I gave you. I've posted the answer key onto Google Classroom. Work those out, and then if you got any wrong, identify those. Come to class next week ready to ask those questions, okay? Sorry this video was a little long. Keep up the great work.